Okay, today for fun, it looks like we'll be doing the composition of functions. So first of all, let's just remember how a function works. For example, if I start with my good friend f of x, if I decide to plug in the number 7, I do 3 times 7, then I add 5. If I start out with negative 1, I do 3 times negative 1, and then I add 5. If I start out with 100, I go 3 times 100, then I add 5. So anytime I plug in anything to function f, I multiply whatever it is by 3, and then I add 5. So what if we take the function g of x and plug that in? Well, anything I plug in, I got to multiply by 3. So I'll have to do 3 times g of x. After I do that, I can add 5. Of course, g of x is x squared plus 1. Multiply with the distributive property. Combine like terms. There it is, 3x squared plus 8. So this is what we call composition of functions. F of g of x. Now, depending on what math textbook you look at, or what online resource you look at, or what your future college or university professor decides to do, you might also see it written as f of g of x. It looks kind of like fog, although that's not the letter O, it's a smaller symbol. It looks like the degree symbol, but it's not placed as superscript the way a degree symbol would be. Oh my goodness, the exact same two functions. What if we plugged things into g? G of 7, well, I'd square 7, then I'd add 1. G of negative 1, well, I'd square negative 1, then I'd add 1. So anything that we plug into g, first we better square it, then we better add 1. So what if we decide to plug in f of x? Well, we'll square it, and then we'll add 1. Of course, what is f of x quantity squared? That's right, we got to do some FOIL. First outer inner last. Then, of course, combine like terms. And ta-da, we've got a beautiful answer. So again, anything I plug into this f of x, and notice this f of x and g of x, these are new functions, new and improved. Anything I plug into f of x, first I got to multiply it by 6, then I got to subtract 7. So whatever g of x is, I'll multiply it by 6, and then I'll subtract 7, and there's the lovely answer. Opposite direction, what if I take f of x and plug it into g of x? Well, anything we plug into g of x, we have to square it. So I'll plug in f of x, I'll square it. That means I'll have to use FOIL in this case. Combine like terms, beautiful answer. Now, just for fun, we got one special little surprise coming up here. A new f of x and a new g of x. Oh, f of g of x. Well, anything we plug into f, first we better multiply it by 2, then we better add 9. So let's take g of x, let's multiply it by 2. After we multiply by 2, we better add 9. We just got x, that's kind of weird. Let's try the opposite direction, g of f of x. Of course, anything I plug into g of x, first I have to subtract a 9, and then I divide that quantity by 2. So we'll plug in f of x, we'll subtract 9, we'll divide by 2. Same answer. Oh, do you see what f of x and g of x are? They're inverse functions of each other, aren't they? So anytime f of g of x equals x and g of f of x equals x, then f of x and g of x are inverse functions of each other. So this is a way we can check to see if two functions are inverses of each other without actually trying to find the inverse of each function, or without trying to graph the two functions and see if they are a mirror image of each other on the line of symmetry y equals x. Short and sweet today. Again, I recommend you try to take a stab at the worksheet first, get some feedback from me. get some assistance from NEAT-B, and then if the worksheet gets completed, start working on the IXL in class. If you do not get time to start in class or do not finish in class, it becomes homework. Again, a score of 80 or higher is considered full credit for the assignment.